Hey, algebra students, Mr. Lawrence here, and it's getting late and I'm getting tired, but I just gotta make this video. I gotta tell you, this Common Core stuff, it's crazy. It's pushing you and me to such a higher level. I think it's a wonderful thing. Just keep doing your best. You deserve to do your best. Don't get bogged down. Don't play the I don't know card. Don't close your book and run outside and play basketball, go on a bike ride, or texting your friends. Do your best, and I'm telling you, you're going to start to see math in ways that you never thought of it before. I just either rediscovered something I had forgotten, or perhaps I learned it for the first time. But I saw a connection tonight that I don't recall learning before, and I called Mr. Newman from the high school, gave him a text. He called me back just to make sure my thinking was correct. But it feels good because I feel like I'm learning. When I feel like I'm learning, I feel smart. I feel intelligent. I want you to have that great feeling too. So anyway, the test, this math class has been different than anything you've ever taken, right? Well, you can assume that the test is going to be a little different than anything you've ever taken. So this video is going to try to help you get ready for the test a little bit. All right, now before we actually get to the problem, I need to ask you, if you drive for 3 hours, hey, that's a time, isn't it? Yeah, that sure is. That's a time. At a constant rate of 28 miles per hour, well, that's a rate, we just said a rate. How far did you drive? Well, heck, distance equals rate times time, right? I'm going to leave my distance as my variable. It's unknown. I know my rate is 28 miles per hour. Hey, by the way, I'm going to write miles over hours. Show you something really cool that I realized this back on my own when I was taking chemistry in high school. And then we have, 3 hours. And if you remember Wonder Woman is able to cancel things out with her magic bracelets, right? She cancels out this way. Now, as I look at these two fractions being multiplied, I don't see any numbers that'll cancel out, except I do see some labels that'll cancel out. I see hours over hours. Can Wonder Woman cancel those out? You better believe she can. And so this is really cool because in a math geek kind of way, because I'm going to do 28 times 3, and I'll get a 4 and then a 2 and then 6 and 8. So it's going to be 84. But what label is left? Oh, I should have put an MI there. Sorry for miles, otherwise it's meters. Miles per hour. Well, the hours canceled. I'm left with only miles. Do you see what I'm trying to say? How far did you drive? Not 84, but 84 miles. Why is it miles? Because when I multiplied the miles over the hours by the hours canceled out. Just like the numbers do. Yeah, the labels work the same way. I'd be willing to bet that down the road, you might be doing something with variables, and they're going to cancel out in a similar way. You just have to remember Wonder Woman, and remember to cancel all 4 directions, if possible. All right, now, what if you drive for 20 minutes? That's a time at a rate of 30 miles per hour. Well, you cannot do this. You can't do this. Rocky, are you listening? Don't do this. Don't do it. Anthony, don't do this. Taylor, are you checking me out here? Don't do it this way. Don't go distance equals rate times time. Leave distance unknown. Put the rate of 30 miles over hours in, and then go times 20 minutes. You can't do that. You can't do it. The speed, the rate is in miles per hour. So you can't use minutes. You have to use hours. So if I have 20 minutes, and I know that 1 hour, looks like an N, sorry. 1 hour is 60 minutes. If I multiply that, first of all, Wonder Woman's going to show up. And, I left the minutes off, sorry. The minutes will cancel with the minutes. And then I can cancel the fractions. 20 60 is going to turn into 1/3. And so when I multiply, I'm going to get 1/3 of an hour. And so I'm going to use 1/3 in my problem. So let me use the 30 miles per 1 hour, right? And I'm going to multiply it. And I wish I was in my calligraphic pen. Oh, it says I am. That's strange. Doesn't look like my calligraphy pen, but okay. And I'm going to multiply that by the 1/3 of an hour, right? Okay. And the hour's in the numerator. And look at that. Wonder Woman is going to cancel the hours. 3 is going to go in 3 once. It's going to go into 30 10 times. And so I'm going to get 10 miles. Okay. 10 miles. What about 75 minutes? Well, again, now I could think about it as 1 hour and 15 minutes, right? But then I got to take the 15, not 16, Mr. Lawrence, 15 minutes, going to multiply it by 1 hour over 60 minutes, and then the minutes will cancel. 15 over 60 is going to simplify to 1/4. And so when I multiply, I'm going to get 1/4 hours, or 1/4 hours, okay? So my distance is unknown, and then I put my rate of 43 miles. And remember, per is divide, okay, per hour. And I'm going to multiply that by 1/4. And then hours is in the numerator. Okay. And now Wonder Woman's only going to cancel the hours here. But I'm going to get 43 divided by 4. Okay. Now, if this was 44 divided by 4, wouldn't the answer be 11? Right? 11 miles? Well, I'm 1/4 short. So the answer must be 10. And what's 1/4 short of 11? 3/4 miles. 10 3/4 miles. Or you could have written it like this. 3/4 as 75 hundredths. Either one is acceptable. Don't make it difficult. Make math easy. All right, now, here's one last one, and then we're going to get to the actual problem. I got to warn you, this is going to be a little bit of a longer video. I don't know exactly how long it's going to be because I can't see the time that I'm doing. I didn't notice what time I started. I need to make a better effort to do that. Okay, anyway, 8 hours, 15 minutes. Well, I know 15 minutes is 1/4 of an hour because I just did it. I'm going to work smart, not hard. So my distance is going to be 72 miles per hour times 1/4 hours. Okay, hours are going to cancel. And I believe 4 goes into 72 evenly. I'm going to cut 72 in half and get 36. Cut that in half, I'm going to get 18 miles. So if you drive, oh, wait. Sorry about that. That's only for 15 minutes. I forgot to do the 8-hour part. It's getting late, like I said. All right, so now I also have to do the 72. What I should have done was done 72 times 8 1/4, but that's okay. I can do it this way. All right, 72 times 8. And if I double 72, I get 144. If I double that, I get 288. And if I double that, I'm going to get 576, I believe. So I'm going to take that 576 miles, and add the 18 miles to it from before. And I'm going to carry the 1, and I'm going to get 594 miles. Now, by the way, I love little mistakes like that because, one, it shows you that I'm a human too. And I know a lot about math, but I'm not perfect. So it's okay that you're not perfect as long as you're doing your best. But how do you suppose I knew I'd made a mistake? Well, think about it. I drove for 18 hours and 15 minutes and I only went 18 miles? It just didn't sound right. So I realized my mistake right away. Okay, so let's get on to this new kind of problem here. Check this out. Shelley lives out in the boonies. One day at noon, she leaves her house and drives due south on South Street. She drives for exactly 20 minutes. So there's a time, right? At a constant speed of 24 miles per hour and arrives at the post office. After spending 10 minutes there, she drives from the post office due west on West Avenue for 12 minutes at a constant speed of 30 miles per hour. Well, there's another time there, and that's a rate, and I didn't label that rate. Use this information to help you answer the questions. Now, because the miles per hour and the time is in minutes, I'm just going to go ahead and convert them right now. I'm going to take 20 minutes and I'm going to multiply it. There's 1 hour, 60 minutes. And, if you're wondering why I don't put 60 minutes over an hour, it's because I want Wonder Woman to be able to do her thing. So, I believe this is going to end up being 1/3 of an hour. Okay, 1/3 of an hour, yeah. So that's 20 minutes. All right, now the other time was 12 minutes, right? So I'm going to take 12 minutes and I'm going to multiply by 1 hour over 60 minutes. And the minutes will cancel, right? I guess I can put that over 1 to help you. And then I believe 1260, this is going to turn into 1/5. So I have 1/5 of an hour. Okay. Now, when Shelley's at the post office, what is the shortest distance to her house? Well, hold on a second. Let's get a picture going here. First of all, I have Shelley's house. So let's draw her house. Okay. And it says that she drives due south on South Street. So she goes like this, right? And then she hits the post office. What's the post office? Okay, and I guess I can just put a little thing there. And then she drives due west from the post office, I think, to the laundromat. Is that what we said, the laundromat? Okay, so the laundromat is over here. I'm just going to call it the mat. Okay, all right, now let's go back to the problem here. She drives for 1/3 of an hour at a rate of 24 miles per hour. Well, I'm going to check out the distance equals rate times time. And I know the rate is going to be 24 miles per hour times 1/3 of an hour. Wonder Woman doing her thing here. And look at that. We get a distance of 8 miles. Okay, 8 miles. So that means that this here is 8 miles. Now, what was that question? It said, when Shelley is at the post office, what is the shortest distance to her house? Well, that's going to be 8 miles. And my work is on the other page, okay? All right, now, what is the shortest distance from the laundromat to the post office? Well, let's see here. The laundromat to the post office, she drove at a speed of 30 miles per hour. So she went 30 miles per hour, and she did that for 12 minutes, which was 1/5 of an hour. Okay, so Wonder Woman comes along, blocks some bullets right there, blocks these bullets, and look at that, I get 6 miles. Yeah, it really isn't that hard. There's a lot going on in the problem, but it's not anything you don't know how to do. So the shortest distance from the laundromat to the post office is 6 miles. Okay, you're going to get to practice this kind of stuff in class. I'm just walking through this problem. All right. You know what? There's a typo right here. Let me go ahead and fix that. It's supposed to be right here, the laundromat. Laundromat. What is the shortest distance to our house? Because I already answered the question for part C. So let's go back to the problem. And hey, what do I have going on here? This is South Street and this is West Avenue. Don't I have a right angle right here? Oh, I sure do. I'm going to color it in. It looks so pretty. Hey, the shortest distance to our house would be from the laundromat to our house. If there's a road there, we don't know if there is, but that would be the shortest distance. I see a right triangle. How do I find the missing side of a right triangle? That's right, I use the Pythagorean theorem. The Pythagorean theorem, yes, very good. I'm going to use it to find this distance. And so my hypotenuse is the side across from the right angle. That's my variable. So x squared. And then I'm going to put 8 squared plus 6 squared in. And that'll be 64 plus 36 equal x squared. If you're still having trouble with the Pythagorean theorem, make sure you come in and see me, please. It's so simple. I'd love to help you with it. All right, so when I do this, I end up taking the square root of each side. And I remember the square root of 100 is plus or minus 10. But since we're talking about a distance, a negative number doesn't really make sense. So we're going to just go with a positive answer. So this is 10 miles. Okay. Now, I think I can answer that. That's part C. So that'd be 10 miles. And again, all my work is shown just on another page. Okay, what is the shortest distance to Shelley's house when she's driven for 4 minutes on West Avenue? You know what I should do is I should convert 4 minutes to hours. Yeah, 1 hour over 60 minutes. And so that's going to go in once, go in there 15 times, and so that'll be 1/15 of an hour. Okay, instead of 4 minutes. I know I'm going to need to do it, so why not just do it? So remember, West Avenue, she's traveling at a rate of 30 miles for every hour, right, per hour. And the time is going to be 1/15 of an hour, and that'll give me the distance she has gone. Wonder Woman does her thing. Wonder Woman! Ah, there we go. And 15 goes into there twice. And so it looks like she's gone 2 miles. Okay, now I'm going to clean my picture up here a little bit. I'm going to get rid of the 10 miles because I don't need it. Get rid of that. And I'm going to get rid of the 6 miles because it's not going to be accurate. So it looks like she's gone 2 miles. And so that's about there. And so now I'm going to use the Pythagorean theorem on this part here. Do you see what I'm doing? Okay. And so I'm going to set up the Pythagorean theorem, and I'm going to call the hypotenuse, maybe I'll call it y because I called it x in the last problem. So I'm going to say a squared plus b squared equals c squared. Y is my unknown in this case, is c. So like that. I'm going to have an 8 squared plus a 2 squared. And when I do that, I'm going to get 64 plus 4, and that's going to equal y squared. 68 is going to equal y squared. And I'm going to take the square root of each side. And I did this earlier tonight. I believe it comes out to be just shy of 8 1/4. Let me double check it again here. Square root of 68. It's like 8 24/100. It's pretty close to 8 1/4 if I round it. So I'm just going to call it y is approximately 8 25/100. 8 1/4. I'm going to go with that. Okay, so where am I at here? Okay, so her distance is 8.25 miles. All right. Now, what's the shortest distance when she's gone 8 minutes on West Avenue? Well, I'm going to take the 8 minutes and I'm going to multiply it by 1 hour over 60 minutes. Okay, this fraction isn't going to come out as pretty, but the minutes will get canceled. Let's see, 4 is going to go into there twice. Go in there 15 times, and so I'm going to get 2/15 of an hour, which makes perfect sense, doesn't it? 4 minutes was 1/15, twice as long was 2/15 of an hour. All right, so I know that she's going a distance, okay, 30 miles for every hour. And we're going to multiply that by 2/15 hours. And then the hours are canceling. 15 is going into 30 twice. 2 times 2 is 4. The distance is going to be 4 miles. Okay. Now, that's not the actual answer to the question. That is the answer to this Pythagorean theorem problem over here. You see, she's going to be here, which is a distance of 4 miles at that time. And so now I'm going to be figuring out that pink line, or pink line segment, and I guess I'm going to call it Z. All right, I'll just call it Z. And so let me come down here and do my work. My a squared plus b squared equals c squared. C is the unknown again. It's not always the unknown, but it is in this case. And I think I'm going to have 4 squared and 8 squared once more. Oops. That looks like 82 squared, so I won't do that. 8 squared. And then I'm going to get 64 plus 16 equals z squared. That's going to be 80. This answer is going to be really close to 9. How do I know that? Because the square root of 81 would be 9. Yeah, it's going to be really in the high 9, or high 8.9 something. All right, so z is going to be approximately, and it looks like 8 94 hundredths if I round it to the hundredths place. Okay, so that's the actual distance. So 8 94 hundredths miles. Okay, now they want me to make a graph. All right. Well, let me get to a blank page. Let me get some graph paper out here. Let's see my content. Okay. There we go. All right, now I'm going to lock that in place. And let me think here. I'm going to do the distance, shortest distance from her house versus time. So I want my time in minutes, right? And then my, let's see, shortest distance to home in miles. And let's see if I can just, yeah, that's okay. It's a little bit sloppy, but you'll forgive me, right? Okay, now the time that the person took to travel, I think the total time, geez, I gotta go back to the problem. I don't remember. Okay, let's see here. All right, so let's see. Noon, she drives for 20 minutes. And then she's there for 10 minutes. So I'm up to 30 minutes. And then she drives for 12 more minutes. So it looks like I'm up to 42 minutes. So it's going to go up to 42 minutes. So if I count by twos, 4, 6, 8, 10 minutes there, right? 1, 2, 3, 4, 5. That'd be 20 minutes. 1, 2, 3, 4, 5. That'll be 30 minutes. 1, 2, 3, 4, 5. That'll be 40 minutes. I'm actually going to go a little bit off the graph, but it's such a small amount. I don't think it's a tremendous deal. But I could even do this. Let me get it right here. I can get it right on. It won't change the way anything looks. Yeah, it looks pretty good. There we go. And so that'll be my 42 minutes. And if I want, I can... Yeah, there's too much going on to change. Oh, there it goes. Let me do it. So I can take that axis over a little bit. Okay, now, how far does she end up from her house? Well, 10, right? So I think I'll make every 2 blocks a mile. So that would be 1 mile. There's 2. There's 3. There's 4. 5 miles. 6 miles. 7 miles. 8 miles. 9 miles, and 10 miles. Now, right off the bat, I know at noon, she is at home. Boom, right there, right? She's 0 miles from home. She's already at home. And I also know that at 42 miles, she's going to be, or 42 minutes, she's going to be at 10. You know, the temptation is going to be just draw a line segment. No, we can't do that. We can't do that at all. So, let's go back to the story and see what happens here. It says she drives for 20 minutes at a speed of 24 miles per hour. That's to get to the post office. And it says right here that she went 8 miles. So I'm going to go 20 minutes and take her up to 8 miles from home. Now she drove at a constant rate. It's not like she was falling and gravity was pulling on her. So because she's going at a constant rate, I can just do that line segment. Well, furthermore, I know she spends 10 minutes at the post office, and so her distance from home doesn't change for those 10 minutes. Now, the really kind of strange thing is, and you know, I'm not necessarily going to test you on this part specifically. This part of the graph is going to behave like a circle, and I know this because you'll do later on, not this year, but you'll do either in geometry or in algebra 2, you'll work with circles, and their equation has usually a square plus a square equal to a radius squared, which looks an awful lot like the Pythagorean theorem. I'm giving you a very simplified version here, but so because the Pythagorean theorem is actually some type of circle relation. It's kind of cool in a way, and that's the thing I discovered tonight. So what I am going to do is I'm going to plot the points I got here. Where's my answers? Okay. When she's been going for 4 minutes, she's at 8¼ miles from her house. So let me go 4 minutes from the post office. Okay, so that's 2, 4, and she needs to be at 8¼ which is going to be there. Okay, and then when she's gone for 8 minutes, she's almost at 9. Remember that square root of 80 that I said was going to be very close to 9? Yeah, that's the other one. And so you see those points, this one here and the black one, they are not linear. No, this is like a curve. And you will study this kind of thing a little bit later. Anyway, there you go. So there is a rough sketch of that graph. All right, this was a very long video. I thank you for your patience. I'm glad I got it done. I think I've been going about 30 minutes. I will say good night, everybody.